Okay, so this is going to be a crazy margin of error here. We've done a little bit on margin of errors. Let's just talk a little bit here. So this does not cover everything. I'm going to go into my TA84. I'm going to click the stat button, scroll over to the right to test, and we have the lists of all the most common hypothesis tests and confidence intervals, yeah? Okay, so I'm looking at the tests. For every test, there's a confidence interval. For every confidence interval, there's a test. Yeah, typically this is kind of the basic palette. We have Z interval, yeah, when we know sigma. We have T interval when we don't know sigma, we only know S. And we use a T distribution. Sometimes they call it the student T distribution. Okay, so we have the two sample. We haven't done two sample yet. This is our first two sample video. Two sample Z, yeah, that's a two. Sample T, all of this is about the mean. What is this to estimate population mean actually? So we use sample data to estimate population mean. Yeah, so what these would be over here, two independent samples, this would be to determine the difference between two means. Yeah, determine the difference between two means. So we also have a one prop Z int. I'm just doing this because I kind of feel like lecturing. That's a proportion. And it actually does use a normal distribution, a Z distribution, which is normal. So we have a two prop. Yeah, two prop Z int. Two prop Z int, which is the difference between two proportions. Yeah. So that's what that thing is going to be in the background. What is this? This is specifically a confidence interval. Two prop Z int, that is what it's called. So it doesn't even end there, but that's a lot of the basics. Two prop means proportion. Two Z int, and it is the difference between two population proportions is what that's going to be. It's kind of like a hypothesis test. You compare them, the difference between two proportions. Yeah. If the interval contains zero, then there's no evidence that there's a difference between the proportions. If the interval is only positive or negative values, then you have evidence, statistical evidence perhaps, that there's a difference between the two population proportions. So it's it's not a thing. It's the same as one prop. We get all this stuff and it looks so crazy, but we just literally plug everything in there. So it's very similar to before. Now I'm going to try something. We try this instead. Let's see if this works here. But I have my stats. I'm just going to type everything into 2 prop Z int. Yeah, so x1 is 43, n1 is 50, x2 is 94, n2 is 94, x2 is 94, n2 is 111. This is fine. Evaluate E. We can evaluate that. Oh, they have to give us a confidence to find the Z, but they gave us the Z anyways. Yeah, what is 2.58? What does that mean? So there's more than one way to kind of do the thing there. Okay. So I was going to try and do the calculator method that's in there, but let's just go ahead and plug into that and see if we can do that. So what is Z? It's 2.575. Yeah, what is P hat? 1. X1. Oh, they make us do all of that in there. Yeah, that's a lot. Okay, so P hat 1, 43 over 50. Yeah. And then this is going to be 1 minus the answer. And then N1 is 50. And then plus P hat 2 is 94 over 111. And this is 1 minus P hat divided by N2, which is 111, and it is the square root of that whole thing. Let's see if we can do that. So for E, I'm getting approximately what? All we really care about are the careless mistakes. That's what we care about here. Okay, so I got 0.15. What do we want there? We want 2 decimal places. What I got is 0.1540. Oh, this is a quiz. 0.1540. So they might be monstrosities of problems. Okay, so that's the test statistic. Yep, that is the test statistic for a difference between two means, independent sample. We can plug into that thing right there. Yeah, a two sample t-test is what it is. So they have to give us the alternative hypothesis, but for this one problem, for the test statistic, they actually don't. So I plug all of that in there, I'm getting negative 1.47. Eek again, so we have to do the quiz. Okay, so if we understand a lot of the different confidence intervals in a hypothesis test, they're just seeing if we know how to plug into a lot of these test statistics, margin of error things. Basically what that is. So let's see if I can do all of that in one fell swoop there. That's 0.81. I literally type it into my calculator this way. That Z star is 0.81. It's 0.77 parentheses squared over N1 plus 0.66. Yeah, that's going to be squared divided by N2, the square root of the whole thing. So that's what I'm trying to type in. You do it in pieces. You don't have to type it in all at once, but it's okay to type it in all at once. So 0.21. So F means do that. It's 5.94 squared divided by 5.41 squared. We don't need any fancy algebra, absolutely not. but it's also 5.94 over 5.41 quantity squared. Yes, it is. Okay, so plug into the equations is just boring old that. This is going to be for a difference between two means independent samples z, because we have sigma as opposed to s. So sigma 1.95, sigma 2.69, 97.5, and 1, 13, 97.36. Yeah, what is this one right here? Evaluate the following, so we just do this right here is fine. P bar, Q bar, I'm wondering if we have, yeah, so we have to do their equation. Okay, so they do this sometimes. I wish they kind of told us, because I honestly kind of forget here. Maybe they tell us right there. Uh, to evaluate the formula, substitute given values of corresponding, obviously know how to do that. So they don't tell us what the thing is. They just tell us how to calculate all that, which we already knew. But those are going to be different values there. If you want an example problem, here's one we can slowly scroll through it there. But pooled data, I think pooled, I was just wondering, sometimes they do the p-bar, sometimes not. They do a different mathematical method for the test statistic, which is what that is. That's what I was wondering about. But okay, so the p-bar is that. We just have to go through and calculate the heck out of all this stuff. So let's kind of do this here. Yeah, p-bar. Hmm. So q bar is just 1 minus p bar always. Q bar equals 1 minus 0.1561. That's all that is. Okay, so everything there should be pretty self-explanatory. I think we just plug all of it in. P1 minus P2 is always 0. That's the null. Yeah. Okay, so let's see if we can plug all that in the calculator. That equation, I literally get 6.08. Okay, so mu d equals 0, that's d bar. This is the difference between two means dependent sample. The d bar is the average of mean 1 minus mean 2. Once we kind of get past this, we talk more in detail about what these are. This is more of like an algebra exercise here. But if we plug into that, I got 1.024. Yeah, they want 3 decimals again. Okay, so this is that same crazy equation here as all this thing is. P bar. Yeah, they give us this easy one, then they finish us off with one of those other crazy ones. Plus 76 divided by, I say 90, is that 126? Okay. So we're going to have 0.7937. Okay, so we have this here. Yeah. Okay, so let's see if I can kind of plug all that in on one fell swoop. I see 0.9. Yeah, 0.9 minus 0.2, that's 0.7 anyways. Divided by the square root. Yes. So we are also saying that this really doesn't matter. It's just some of us can't help if we really like algebra. The bottom of the fraction, this is another way to write the bottom of the fraction. So divided by the square root of p bar, which is 0.213447 times q bar, and they should add to be 1, 0.786, 553 times 1 over n1 plus 1 over n2, 1 divided by 89, plus 1 divided by 93. Another exciting video. So here I am getting 11.52 to 2 decimal places. 100%.